This is lesson 8.1, polar coordinates. We're going to formalize what we were talking about on block day about polar coordinates into our guided notes. So I want you to take out your guided notes and fill in as you follow along with the video. So as we talked yesterday, a polar coordinate system uses two things. It uses a distance, meaning the radius, and a direction, and that direction refers to an angle. Okay, so in this problem here, we're looking at this, and we want to go this route right here, this what I'm going to call this pole, okay, this pole right here. And I'm going to follow that pole to this point right there, r theta, which means we went some distance and at some angle. The distance is the radius of a circle that point is on, where when we started, we would have been standing right here at the origin. We would have turned a certain degree, certain angle, and then walked the radius to that location. Because remember, a point is a location. So this is just another way to describe how to get to this location. We turned an angle and walked a radius. So we're going to do some points here and plot them in the polar plane here. Remember that if your r is greater than 0, if your radius is greater than 0, meaning positive, it says stay in the quadrant you landed in. What I say is you walk forward. You walk towards the ray that we're talking about. When your radius is negative, you're going to back up on that pole. Okay? The angle, when the angle is positive, greater than 0, you're going to rotate counterclockwise, like we've always done with the unit circle. And when your angle is negative, you're going to go clockwise. So for point, we're going to, and I always like to say, start with the spoke or the pole. Start with that spoke. So when I look at this first point, 1, 3 pi over 4. I want to start with the angle, start with that spoke. And I look at that angle, there it is, there's that spoke that I'm looking at. And once I identify my spoke that is pointing at 3 pi over 4, I'm staying at the origin. The radius says how far to walk. Well, I just walk one radius. So I put a point right there, and then I don't have the spoke outlined. I'm just was kind of focusing my eyesight on that spoke. In problem number 2, we're looking at the spoke negative pi over 6, which is that spoke right there. We went negative this way, and this says walk out 3. So we're going to count out 3 radii, and there it is. It's a circle with a radius of 3. And we put a point. We don't need the spoke outline, so we get rid of it. We just have that point, and that's point number 2. For point number 3, again, we identify the spoke pi over 4. But we're going to walk backwards. And the reason we know we're going to walk backwards is because it says negative 4. So the spoke would have gone this direction, but from the origin, instead of walking towards pi over 4, we're going to walk backwards this way, and we're going to count out 4 radii. And there it is, and that would be point 3. For point number 4, we're going to identify 3 pi over 2, walk out 2, there it is. 6, we find negative pi over 3. There it is. But and again, we counted backwards for negative pi over 3, and then we're going to walk backwards because it says negative 6, and we're going to put a point at negative 6. We counted out 6 radii, and there it is. For problem number 6, we're going to identify the spoke 7 pi over 6, and we know we're going forward since it says positive 5. Count out 5, put a dot. For point number 7, identify the spoke 5 pi over 3, back up 2. For number 8, we're going to identify the spoke negative 5 pi over 6. Remember, we're counting backwards this way, counting clockwise. 5 pi over 6, identifying that spoke. And then it says to walk out 1. And so we just go to 1, and then there's the point for point number 8. For point number 9, we identify negative 11 pi over 6. So we're going all the way around that way to find negative 11 pi over 6. And then we walk out 2. For the last one, we identify the spoke 4 pi over 3. And we're going to walk forward 3. And there it is. And so those are the 10 points that are plotted. You have those now in your guided notes. When we're going to convert between polar and rectangular, we know that Rectangular is in the form of x comma y, where polar is in the form r comma theta. Even though I like to think of the angle first and then the radius, it's always written in this fashion, r comma theta. Just like we don't say y comma x, we say x comma y, okay? And then it says this means that the rectangular equation is in terms of x and y, and the polar equation is in terms of r's and thetas, okay? So we have some conversions. And the first one that we learned and we did in our activity on block day was that to find our x's, we take r and theta and we do r times cos theta, and that will give us the value of x. So this is how we take polar and convert to rectangular. And also we need the y value, which is going to be r sine of theta. Now remember when we did the unit circle, we always talked about the y-axis was the sine axis, so that's how you can think of this. To find the y values, the numbers that go on the y-axis, we do r sine of theta. To find the axis, remember the x-axis was the cosine axis, so it's going to be r cosine of theta. When we plug in our r and theta, we will get our x and y. So this is going from polar to rectangular. What about equations? Well, we have this that we know that r squared, the radius squared, equals our x squared plus y squared. We can also write this as r equals the square root of x squared plus y squared. But we're just going to write down this conversion. If we have our x and our y, we plug them in, we can find our r. If we have an r squared, we can rewrite it as x squared plus y squared. So we use this for equations to help convert from rectangular to polar and from polar to rectangular. Well, what about the angle? Well, to find the angle, if we have our rectangular, y, x, and y, we do the arc tangent of y divided by x, and that will give us our angle. But don't forget that also means that if we have our angle, we will have the ratio of y divided by x. So let's do some converting. We've got polar. There's 4 different points here that are in polar. We're going to use converting from polar to rectangular. So we're going to be using r sine theta and r cos theta. And then we have our r and our theta. We plug it in and we evaluate. So for our x, we get -2. For our y, we get 2 root 3. And so the point in rectangular is -2 comma 2 root 3. We're going to do the same thing for point 2. We plug in our r and our theta, and we evaluate each one of those, and we get x is equal to x is equal to 0, and y is equal to -1. Whoops, and I have a mistake, so let me fix that. Okay, there, now it's right. Yeah, it's 0 comma -1. And that's the coordinate for the rectangular coordinate when we're given the polar form. I want you to do problems 3 and 4. Pause the video, convert those two, and then resume the video, and I'll show you the work. Okay, the hope is that you have now paused the video, you've done problems 3 and 4, and we're checking your answers. For problem number 3, we plug in 0 and 13 pi for our r and theta. Evaluate, and we get 0, 0. We plug in root 3 and -5 pi over 3 for our r and for the r and theta for problem number 4. Evaluate, and we get root 3 over 2 comma 3 halves. Now let's talk about equations. These are a little tricky. You'll get the hang of it after you do a few of them. But we know we have these conversions. Whenever we see r squared, we can replace it with x squared plus y squared. Whenever we see r cos theta, we can replace it with x. Whenever we see r sine theta, we can replace it with y. So I'm looking at this, and first of all, I don't see an r squared, and I don't see sine or cosine. So my first thing is, I'm thinking, I wish this said r squared. So one of the things I could do then is simplify this. Oh, I'm sorry. First, I change it with sines and cosines. And then what I can do here is I can say, let me multiply both sides by cosine theta. And then you go, oh, look at that, r cos theta. So by changing secant into 5 over cosine, because it was 5 secant theta, I've got 5 over cosecant theta, multiply both sides by cosine theta, and now we say, oh, our cosine is just x, so this is x equals 5. This happens to be a vertical line, if we were to graph it, at 5. Problem number 2. In problem number 2, I only have an r, and I need to have r squared. I happen to have a cosine theta, but I need a r cos theta. So I'm going to multiply everything times r. Again, these are little techniques we start learning on how to do the conversions. I need to see an r squared, and I need to see an r cos theta or an r sine theta. So by multiplying everything by r, I'm going to get an r squared. I'm going to get a 2r. We'll deal with that in a minute. And we're going to get 2r cos theta. So the r squared can be replaced with x squared plus y squared. The r cos theta can be replaced with x, and we have this. Now we still have this pesky old r right here. So what are we going to do? Well, let's isolate the r. To do that, we're going to subtract x, and then we'll keep the 2 with the r. Now what I want is an r squared. I don't want to introduce another r here, so I'm not going to multiply both sides by r. But how could I make this have an r squared? Well, I could square both sides of the equation. I'm going to leave this with the square. I'm not going to simplify it. I'm just going to write it as that squared. But the right-hand side becomes 4r squared. And there's my final answer. I exchanged the r squared with x squared plus y squared. We don't need to simplify this any more than this. It's perfectly fine to leave it like this. So there's no more r's. There's no more thetas. Everything's fine. Okay. Problem number 3. It just says r. I could multiply both sides by r, but then I'd have a negative 4r over here. I don't want to do that. So instead of multiplying both sides by r, I'm just going to square both sides of the equation. And I get r squared equals 16. R squared can be replaced with x squared plus y squared. What about number 4? Number 4, well, we have this theta equals pi. And I want to think for a moment and say, well, we have the equation that says theta equals tan inverse of y over x. So could I just replace that with it? Yeah, but we don't really, it doesn't look good. We could do it, but there's an easier way to do that. If this is true, this is true, theta equals the arctangent of y over x, then that means that tangent of theta equals y over x. So if I just took the tangent of both sides of that equation, tan of theta and then tan of pi, well, tan of theta we just talked about here. Tan of theta is y over x. So I can replace this tan of theta with y divided by x. And tan of pi is 0. So we've got y over x equals 0. Now, we've talked about this in class, and we said, what's the only way that a fraction, y divided by x, could equal 0? There's only one way, and that is if the numerator were equal to 0. So finishing up this problem, we get the equation y equals 0. And that is the rectangular equation for that polar equation. For this polar equation right here. Okay? All right, let's convert from rectangular to polar. This time we have x comma y in all of these problems, and we're going to use our conversion. Now, we used to say r squared equals x squared plus y squared, but we want to find our r. So we're just going to do x squared plus y squared and then take the square root. For our theta, we're going to do y divided by x and then the arctan. Okay? We need to check the quadrant because arctangent, if we're not careful enough, we're going to only be in quadrants 1 and 4. But these points aren't necessarily in quadrants 1 or 4. They could be in quadrants 2 or 3 or 1 or 4. So we have to check that out. Let's always start with finding our r. So to find the r, we square the x, square the y, add them together, take the square root. And we get 2 root 2. For the theta, we plug that into arctan. This becomes -1, and we should have memorized our unit circle where we know the arctangent -1 is going to be one of the 45 degrees or the pi over 4s. But it could be 1 pi over 4. It could be 3 pi over 4. It could be 5 pi over 4. It could be 7 pi over 4. It depends on the quadrant. I look at this and it's positive and negative. That tells me it's quadrant 4. If it's quadrant 4, then the angle is negative pi over 4. Or I could have said, instead of negative pi over 4, I could have used any coterminal angle for negative pi over 4. I could have said 2 root 2 comma 7 pi over 4. Or I could have said 2 root 2 15 pi over 4. All of these angles, 7 pi over 4, 15 pi over 4, and negative pi over 4, they are all coterminal. And so we can have multiple answers that are correct because it's all about getting to the location. Problem number 2, we're going to do that r equals a square root of x squared plus y squared. Square each of those, add them, and take the square root. We get the square root of 36, which is 6. So we know our r is 6. For the theta, we do the y divided by x, and we note that this is in quadrant 4. And negative 3 over 3 root 3 is negative 1 over root 3, which tells us it's negative pi over 6. And again, I don't have to say negative pi over 6. I could say 11 pi over 6 or any multiple of that. But it's easy enough just to leave it at negative pi over 6. And so the answer is the radius and the angle, 6 comma negative pi over 6. For problem number 3, we square, we add, we take the square root, and we get the square root of 3. Be careful here because negative root 3 squared is 3, and then we're going to have plus nothing, so we have 3, and we have square root of 3. So that's why this is the square root of 3. Our radius is square root of 3. The angle is the arctan of negative root 3. We recognize again that we are in quadrant 4, but we're going, wait a minute. This right here is undefined. Now think about this point right here, rectangular. We went straight down to negative square root of 3. Oh, that's the angle that is 3 pi over 2. And so we have our coordinate is root 3, comma, 3 pi over 2. For problem number 4, we square, we add, we take the square root. And we end up with the square root of 8. The square root of 8 is 2 root 2, so there's our radius. We are going to find our angle, so we want the arctan of negative root 2 over the negative root 6. Negative divided by negative is a positive. Root 2 divided by root 6 is 1 over root 3. So we want the arctan of 1 over the square root of 3. But what quadrant? Negative, that's quadrant 3. So we're looking in quadrant 3 where the tangent would be 1 over the square root of 3, and that would be 7 pi over 6. So our answer is 2 root 2, 7 pi over 6. We still have to use our unit circle to find these things. All right, converting equations. Again, we're looking at those equations. R squared equals x squared plus y squared. We're looking for x is equal to r cos theta and y is equal to r sine theta. I've got an x, so that's going to be r cos theta. I have a y, which would be r sine theta. I am squaring the x, so I've got r cos theta squared equals 4 times r sine theta. I want to rewrite this with the squaring, so I've got r squared and cos squared. I'm going to divide both sides by r because they both have an r. And I have r, and I'm also going to divide both sides by cosine squared so that I'll be left only with an r on the left-hand side. And on this side, we're going to have 4 sine theta divided by cosine squared. And that's the final answer. That's the equation in polar form. We try, if we can, to solve for r. If we can. In this problem over here, we've got x squared plus y squared. Well, that's r squared equals 9. We don't want r squared if we can. We want to try to solve for r. So when we solve for r, we get positive or negative 3. It just means it's a circle with a radius of 3 when we have this equation. Negative 3 would just imply that we backed up to 3, and positive 3 would mean we walked forward to 3. It isn't the same thing as numbers on a number line that we think of. It's the direction we walk to get to our equation. In problem number 3, we've got y, and y is r sine theta, and it equals 5. We want to solve for r if we can, so we're going to divide by sine theta. Now, we could rewrite this, since it's over sine theta, the reciprocal, we could write that as cosecant. If you left it as 5 over sine theta, I'd be okay, but this is where we really want to get to. Now, don't be fooled. This says x squared minus y squared. It doesn't say x squared plus y squared. If it said if it was a plus, then this would just be r squared. It's not. So we have to individually do our x and our y. Remember, this is r cos theta, x is r cos theta, and y is r sine theta. So we do those, and they're both being squared. I'm going to simplify them. So I'm going to get r squared cos squared and r squared sine squared. So I've got this equals 1. I'm going to factor out the r squared. And now I could look at this and go, and you could divide both sides by cosine squared minus sine squared. But I remember we had an identity that said cosine squared minus sine squared, and that was cosine of 2 theta. So now I'm going to divide both sides by cosine of 2 theta. And remember, 1 over cosine is the same thing as secant. So I could say r squared equals secant 2 theta. Now, remember it says solve for r if we can. We can now take the square root. This is fine. I would accept this answer. We can take the square root of both sides, though. And we get positive or negative square root of secant 2 theta. This, I've got a little celebration because this is a beautiful answer. This is what I really, really like. If you left it with 1 over cosine 2 theta, or you didn't even change to cosine 2 theta, and you left it as cosine squared theta minus sine squared theta here, that would be okay. That's the end of our guided notes. And then you have homework that's listed.